quite a bit better. It's constantly crashing on me. Anyway, all right, very good. So that's all I want to say about the affordance-based interaction system. You can watch the lecture recording if you've forgotten it, and you should be good to go. The task hints in your Project 1 spreadsheet also give you a ton of guidance on what you might want to do, what you might want to think about, and how to go about building out this app, okay? All right, so what I want to do, I'm going to go ahead and close Unreal Engine. By the way, if you have trouble setting it up, I'll be here for an hour until 4:30, and I can help you set it up, okay, and answer questions. We got into this lecture. Do you remember the chair? All right, you remember the chair? The chair is, the hammer is not nearly as complex as game engines because its purpose is not nearly as complex. Well, we talked a little bit about scripting, right? We talked about scripting. The main takeaway from visual scripting, if you remember this mess, right? You remember this mess? Hopefully you never have any Unreal Blueprint scripts that are this nasty. But the thing to remember about Unreal Blueprint visual scripting is that it truly is just programming. It's just normal programming. It's just things are represented a little bit differently, okay? Instead of typing the function name, you right-click and then search it up and click it, okay? That's it. And so anything you can do in a textual programming language, anything you did in EECS 281, you can also do with blueprints here. It might be a bit slower. It might take you a bit more time. It might look kind of nasty, but it's possible, okay? So keep that in mind. All right, if you look at these two bits of script here, right? On the left, we have Unity, a textual programming language, C#. On the right, we have Unreal Blueprints, a visual scripting language, right? You notice they actually have a lot in common, okay? We have start up here, which is the lifecycle function that runs when the game begins, okay, essentially. And over here, we have event begin play. Same exact purpose, okay? Down here, we have update versus event tick. They're named slightly differently, but they do the same thing, right? By the way, what is a frame? Have I talked to you about that? If you don't know what a frame is, when I mention frame, okay, think about a painting, okay? A painting is one frame that never changes. You could say that a painting updates itself 0 times per second, 0 frames per second, 0 FPS, okay? Now, a game typically updates 30 to 60 times per second. If you're in VR, you actually want to update about 90 times per second in order to reduce nausea, okay? A film is a little bit less interactive, right? You don't have your hands on the controller. The film isn't like pasted to your face, okay? So 24 frames per second actually looks really smooth for a film. It's just fine. A painting has 0 FPS. As we said, it doesn't update at all. And if you have more frame updates per second, you can see that everything becomes much smoother, okay? 60 FPS, buttery smooth. 30, still pretty good. 15, okay? That is not going to feel good at all, okay? And if your game ever gets overloaded, it might look like this. Let me see. I'm not sure why I can't click it anymore. Whatever reason, YouTube does not like me trying to actually show this video when it's so small. Okay, you know what? This is frustrating. Here we go. Okay, can I finally, will it let me click on the, it won't still. Is it still going to be messed up? Yeah. Well, anyway, you can watch it. It's very smooth right now. As soon as the sandstorm comes in, it's going to start lagging very hard. Okay, watch this. Watch this. Oh, very slow. Oh my goodness. Look at that. Right? The game seems to be running in slow motion. It's running in slow motion. It's running in slow motion because the game is struggling to figure out what the next frame is going to look like. And so it needs more time. And so everything slows down and gets choppier. All right? Not good, not ideal. all right? If this starts happening to you on your computer, then we got to optimize that. We got to get that fixed, okay? All right, anyway, we call these functions start, update, event begin play, event tick, interact. We call all of those lifecycle functions, okay? They are functions that automatically get run at certain really convenient times. So in many games, you want to run some logic right away so that you can set some things up. In all games, you want some ability to run logic, boom, 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 every frame. Otherwise, it would not be a game, right? And so that's why what we mean when we say lifecycle function. It allows you to run code at different moments in the life of the actor, okay? Lifecycle, okay? If you look at these functions, we have debug.log in the textual C# language in Unity, and on the right, we have print string, okay? They do the same darn thing, all right? And over here, we have two different ways of moving an object, okay? On the right, in Unreal Engine, we can move the object with add actor world offset. That's a mouthful, okay? But it takes a vector, okay? A vector variable. And over here on the left, we have translate, which is a function in Unity that takes a vector variable, okay? Basically, one of your toughest challenges when going from one game engine to the other is that basically all game engines will have the same core set of functions and abilities to help you make your game, make your app, make your simulation. But they're named different, okay? They're named differently. And so if you ever get confused in this course and you want to know, hey, how do I spawn an actor in Unity? All right? In Unreal, that's literally just spawn actor node. In Unity, it's called GameObject.instantiate. And that's just how it is, okay? So you will get better at it, but this is something you just kind of have to memorize. What is the analog from one engine to another, okay? All right, and that's what you get. Cool. So when you write code, when the Epic Games developers who created Unreal Engine, when they wrote code, that code gets kind of packaged up into a little bundle, okay? And with that bundle is called a component, all right? And you can see those components here. That constant velocity script, right? These two scripts are the same. One made in Unreal Engine, the other made in Unity, and they just move you like this to the right, okay? Well, they won't do anything until you've added that component onto an actor, okay? In Unreal Engine, it looks like this. I've clicked on the table, that's why it's highlighted in yellow, and then when you look in its little component list, you can see it has that constant velocity component, okay? Right there. In Unity, when I click on this cube, we can also see that, hey, I've added on that constant velocity component, okay? Now, there are other components chilling out there as well. Unity has a ton of them that do things like collisions and physics and rendering, and Unreal just has one, static mesh component, okay? That component is gigantic. It does everything, all right? Okay, and so the code that you write gets bundled up and then slapped on and attached to an actor or a game object, okay? This is really nice, as we saw earlier, because we can take that component that we created, we can add it to many different actors, okay? And it will just work. It's really great. Okay. So the general development flow here is you create a component, you code one up, and then you can attach it to many different objects. You can mix them, you can match them, you can create variables on the component itself that you can then customize, right? You saw that with the message. You saw that with the toggle actors component, toggle actors. We can actually change which lights we want to turn off or on, okay? And for 494 students, how many of you have taken 494? Any of you? Nice. For the 494 students, the note here is that Unreal Engine has very few components that do a lot more stuff. In Unity, we tend to have smaller components that are a bit more broken up, okay? You can also see that each component basically can expose its variables, right? In the Unity script, we had a variable called velocity. We made it public, and so it is visible in the editor itself, in the UI, in the inspector. The same exact thing is possible in Unreal, right? We have a velocity variable that is a vector 3, okay, 3D point, x, y, z. When we make it public by clicking that I, right, it shows up right there in our inspector, in our details pane, okay, so that anyone can edit it without writing any code. Anyway, super, super cool stuff. Yeah, and I think you can actually see that right here. So in Unity, I can actually set that velocity to be 0.01, and the cube moves. But I can change it to negative while the game is being played, and it goes back the other way. I can make it larger, and the object goes faster, right? I can make it go back and forth like a cartoon. It's just very powerful, all right? We're going to talk more about components and why they're special and why it's a really good idea when you're making games or visualizations to use a component-based approach. We're going to talk about that soon, okay? In commercial-grade games, you actually see that lots of different characters and actors and game objects usually have a ton of different components. And if you look at the color coding, okay, you can see that many different objects will share the same components, but in a different combination, all right? It's really nice when you can create new things in a game without writing any new code. That's super powerful. Think about all your teammates that don't know how to program. You're going to have a lot of those when you go to industry, okay? And they can still build cool new things even though they can't program. All right. So we've talked a bit about scripting, about adding logic into your game, right? How game engines support scripting. What I want you to know is that scripting is just a natural result from people's desire to customize their software, okay? Now, do you remember in like EECS 280 or maybe EECS 183, at some point you wrote a program and you run the program and it spits out something, right? You can't really customize it, can you? Right? But then in EECS 281, you wrote a program that could take some command line parameters, right? And the program behaved slightly differently depending on what information you provide, okay? Eventually, you're feeding entire files to the program that really change how it works. And eventually, you want it to be so customizable that you turn it into an engine or you make it moddable. You add a scripting language and boom, now it can do anything, all right? So here's how it goes. You create a basic program, but one day the client, whoever's using the program or purchasing it, wants to be able to toggle some features on or off, okay? Wants some custom workflows. So you say, okay, fine. You add some command line parameters that change how the program works, okay? And that's awesome. Now it's much more flexible, right? Well, the client is not done because now they say, well, the parameters, there are too many of them. The customization is becoming difficult. So now you get to a program that reads a config file. And that config file might be its own language or might have a ton of different features. How many of you have ever set up an Apache server? How many of you have ever done Linuxy things, right? You've got a server running or you've set up a Minecraft server or something, okay? These more complex pieces of software have so many things that you can customize. They have an endless amount of options, so you don't give them command line parameters so much. You give them a configuration file. It'll read the file, and then the file is like 1,000 lines long, okay? Well, eventually, you get to the problem where, hey, I've got really unique pieces of data, like a curve or some math or a map, right? A scene file. And you say, I can't represent that very well in JSON or XML or YAML, okay? So what do? You create some custom tools, okay? This is how I edit dialogue in my game, okay? My horror kind of adventure game. This is called Yarn, all right? And every one of these nodes here that you click on, these little sticky notes, has dialogue inside of it. And this is the yarn spinner editor, okay, where I can actually edit the dialogue that happens, and I can edit the multiple choice options the player gets to say different words or respond, right? This even has support for variables. It even has support for custom commands and if statements and branches. It's amazing, okay? But eventually you get to that point where your data files are so complicated that we have to write special tools to edit them and understand them, okay? Now, eventually, the client wants something crazy. Like they really want Doom to run inside of the application somehow. And you're like, what are you talking about? Well, this is what I'm talking about, okay? This is, let me see. Here we go.
The source code and some of the interesting things about it.
Soon after the source code was released, Doom started to appear everywhere. You weren't sure if it was an elaborate hoax or real, but most of the time it was true. Doom would run on digital watches, digital cameras, ATMs. Even the Amiga received report after John Carmack's insistence that the hardware wasn't powerful enough. With the right developer that's familiar with the target hardware, miracles can occur. But this was no miracle. In fact, the Amiga port of Doom is largely unaltered from the original source code, only with obvious changes for screen, audio rendering, and control inputs. Later ports were rewritten with optimized assembly that can even run on mid-spec 68020 or O30 class processors.
So, Doom is a very popular piece of software. It's open source. It's a famous game. Kind of created the first-person shooter genre, which dominates today. Doom in particular, I'm pretty sure. Let's see, Doom in Excel. Doom runs on Microsoft Excel. Let's take a look here. How many of you have used Excel? Okay. Is that unbelievable or what? So one of the reasons that this is possible is because Microsoft Excel has been around for a long time. And it's possible to add scripting to Microsoft Excel, custom logic to go in and edit cells and perform computations that Microsoft never dreamed you'd want to do. At a certain point, Microsoft is adding new features and new features and new features, and then they give up and they say, you know what, fine. We're going to add a scripting language to Excel so you can add the features you want. Stop asking us for more features. You can make them yourself. Okay? And at this point, you realize, wait a second, Microsoft Excel is a game engine, isn't it? It is. It's not a very orthodox one. Maybe I should talk about Microsoft Excel in the game engine architecture course because it's pretty impressive stuff, isn't it? Anyway, so this is all to say, right? Eventually, you want your software to be so complex that it gets its own programming embedded language scripting system, okay? And suddenly, right? Suddenly, you have a super expressive, almost game engine-like situation, all right? So inevitably, everything is going to get a scripting language if you want it to be customizable to infinity and beyond, okay? And sometimes that happens. So I want to finish up by talking about Unreal and Unity in particular as game engines, because these are very impactful engines. They are a duopoly. They dominate the industry, many different industries actually. And these are your two main engines for this course, okay? We choose Unreal because Unreal, I mean, you've seen it already. Unreal's really good at VR. It is particularly good at VR, okay? And if you want to go into heavy-duty automotive visualization or simulation or film production or AAA video game development, Unreal is the engine you got to know, okay? It's worth spending time with. Now, Unity is really good at AR, and it's really good at mobile games in particular. It's really good at indie games. It can do some bigger games, right, and bigger visualizations, but it's not really meant for that. And so it's also worth learning Unity as well, right? Many research labs use it, and you'll find products everywhere using it, okay? This really is a duopoly. If you go and click on the Get a Job guide and you go to Indeed, okay, you will find a ton of jobs that reference Unity or Unreal, okay? If you just do an Unreal Engine search on Indeed, I think we can do that right now. Nintendo is looking for people in Redmond. Do they want Unreal? Yeah, it looks like they're using Unreal. What about Ann Arbor? Do we have anyone in Ann Arbor who wants Unreal Engine? Okay, Stardock, right? Yep, Michigan's biggest game studio. They're working on some Unreal Engine games. They just hired a bunch of my students out of my game engine architecture course. Yeah, Unreal, Torch Technologies, okay. I don't know what they do. What do they do? Anyone know? They're in Sterling Heights. Yeah, I don't know what they do. Oh, Ground Vehicle System Center. So they're like a vehicle supplier, okay, an automotive supplier. Okay, Tilocity, okay. They look like they do home stuff, maybe home visualization. What else do we got? Okay, Ford, okay. So you can see like there are different companies that will hire you if you know Unreal or Unity. So this stuff is pretty useful, okay. This really is a duopoly. Here's some data. We got up to 2021 by Thomas Bideau. For games released on Steam, Steam games often list the engine, which is why we can get this data. We've got a big chunk using Unreal and then a ton of indie games coming out using Unity, okay? And the other little slices are very minuscule. You can see that Godot, the main open source engine, is and a public domain engine is growing right here. I expect that to continue growing. It's a really great engine. I really want to make another course that uses Godot. But for right now, it's mainly Unity. It's Unreal, okay? Consolidation has occurred rapidly. And what's really been beneficial is that you can use both of these engines for free. This was not always the case, okay? It used to be, like even in the early 2000s, it used to be that you couldn't get a good engine for anything less than $1 million, okay? Just to get them to take your phone call and maybe they'll send you the engine. Need $1 million, okay? These days, you need nothing. You can just download it for free, okay? Now, they will take royalties. If you make more than 100K in a year, Unity will get a cut of that, okay? Unreal lets you keep the first $1 million of revenue, but then you have to pay them, okay? Pay them a percentage after that. All right, these engines have incredible documentation and really big communities. Tons of people use the engine. So if you have a problem, chances are someone else has had that problem and gotten past it, and you can find that solution online somewhere, okay? So really, really good stuff. Unfortunately, this positive feedback loop promotes the duopoly. Here's how that goes. The engines are excellent. Unreal and Unity are really fantastic, right? That causes people to use them. But the more people use them, the better they become. And the better they become, more people use them, and the more people use them, the better they are, okay? And so you can see how a duopoly or even a monopoly is going to be very, very much a thing here, okay? And so no industry is really safe, all right? Advertising industry, right? Did you know that Nike has an internal development team? Now, they don't make games, but they make exhibitions. They make cool little visualizations so you can customize your own shoe, right? You can view new products coming out, right? Quicken Loans has something similar. They don't have a game team, but they have a team that uses game engines to build cool exhibitions and visualizations. Does KFC have a game team? So thanks to the power of modern game engines, you too can date the kernel. Okay, so this is a visual novel dating game. It is very surprisingly well received, and it was very popular. So KFC didn't actually make this internally. They hired a team that has made these kind of games before called PsyOp, but you've got companies you wouldn't expect who are very interested in games and game engines from a marketing perspective, from visualization perspective, from many different perspectives, okay? Research perspectives, defense, military perspectives, okay? You've got NVIDIA building entire cities in Unreal Engine. Why? Because they want a safe way to train their automated driving software, okay? You want to train that stuff in the real world, you need permits, okay? If your car accidentally runs someone over, that's a huge problem. That's terrible, right? Insurance is certainly not going to be happy. That's not going to come cheap. But in the digital world, that stuff's free, okay? It's just not a big deal, okay? So we should accept that the future is going to be very immersive, engaging, and juicy, and game engines are going to be a huge kind of foundational part of all of that. And so learning Unreal and Unity is going to be huge for you, no matter where you go, no matter where you end up. No industry is safe. Unity has recently IPO'd, and Unreal is owned in a big sense by Tencent, okay? And we're almost done, by the way, almost through this. What does that mean? That means both of these engines need to start making some serious coin, okay? They need to start growing. They need to start taking market share wherever they can get it. And so the solution has been to expand to other industries. Gaming is kind of tapped out, okay? Like, yeah, Unity and Unreal already dominate game dev, okay? But if you look at the Unreal templates when you first open up the engine, look at that. Games is the top slot, but now we've got film, live events, architecture, okay? Architecture, automotive, product design, manufacturing, all right? Unreal is trying to expand their turf, all right? And it looks like they're doing a pretty darn good job. Famously, The Mandalorian, have any of you seen that show? It's a big Disney Plus show. Uses Unreal Engine for its acting, for its capture. What happens is you put, in fact, we have a little mock studio back there behind the door. You should look at it. They put up fake virtual screens to form like a wall of screens in a radial fashion. And then the actor actually dresses up, walks through that area, and they can use Unreal to adjust the lighting in real time, to adjust the camera angle in real time. So if they don't like how the scene looks or how the thing is coming together, they can dynamically change it in Unreal in real time. Absolutely incredible. Disney bought like $30 billion worth of ownership in Epic Games in the Unreal Engine maker like a year ago or something, right? Absolutely fantastic. So why Unity and Unreal, right? Because they're fantastic, right? They are fantastic at VR and AR respectively, and we really want you not to learn one or the other. We want you to learn game engines as a concept, okay? Because these engines might not be around forever, but game engines themselves will always have some of these ideas and features, okay? So we want to learn that more abstract concept. Don't get yourself tied to any particular technology. Never do that, okay? How many of you use ChatGPT? Okay? It's a fantastic product, but it might not be the best deal forever, okay? If you get the time, check out Claude. Check out Google Gemini, okay? Don't ever staple yourself to one provider or one piece of technology, okay? Always be looking for the best. Go out and find it. All right. Summary. This is critical knowledge, okay? Yeah, the game engines are taking over many industries these days. There are a lot of opportunities in game engines. And because all game engines have a similar purpose, they will, over time, have similar form, okay? And so, their goal is to promote iteration. In-editor play buttons, stuff like that, easy scripting flows. And when you're talking about engines, you're really answering the question of the what, right? The where and the why, or the how, right? Assets, placement, logic, and other details. However, the most important question isn't something that game engines can help you with, okay? They can answer the what. What is your universe made of? The where do you place them? And the how do they work? But the most important question when it comes to development is why. The why, okay? Why do you choose to make a game themed around, medieval fantasy? Why do you choose to make an AR app that helps people rehabilitate their facial muscles? Okay? Why do you choose to make anything? Why place the character in this location? Why do you program this feature with your limited time versus this other one? Why make an AR app about exploring the hospital and rehabilitating yourself? So these are the questions that you can answer, but you can answer them with your purpose, right? And your life experience. Maybe some big problem or dilemma in society is really personal to you, okay? That is how you're going to answer that question, all right? Not using technology, but by using your own human experience, okay? And your own personality, okay? So please keep that in mind. On P3, you will receive no tasks. You will receive an assignment spec, but it won't tell you what to do or what to make. You'll have to decide that yourself and with your teammates, okay? So please do so. Think about these things as you build up your technical skills, and they'll serve you well once you get to that question of why, all right? That's all I got for you. Thank you for chilling with us. We went a little bit over time. I'm going to be here for the next hour. I'd be happy to help you with P3. I'll be walking around. Just let me know, okay? See you later. All right, everyone online, I'll see you later. This is probably going to be in 2 parts because of the issue in the middle there. And we'll see you later. Bye-bye.